All right, welcome back to another lecture of COM 426, Modern Web Programming. This is lecture 6. We're going to be expanding on our notions of TypeScript and what we can do with TypeScript today to kind of round out our fundamentals module. Thank you. All right, so we're going to get started with some announcements here. The first announcement is that the assignment A02 Pixel Art Maker, that is due next Tuesday at 11. That is incorrect up there. It should say 11:59 p.m. So again, if you haven't started already, please make sure that you do so. And then in addition, some note that if you saw on the syllabus, you have probably been aware, but we're 1 week away from our first midterm. So we're going to go over some of the midterm expectations more next class on Tuesday. I will note, though, that today's lecture is kind of the main end of the content that's primarily going to be on the exam. We're also going to have more content on Tuesday, some of which might show up as extra credit because it helps to round out everything we've been talking about. There will be midterm review, so both midterm review questions and as well as a study guide and other review materials, which should be posted by tomorrow at noon to the website, and I'll make sure to make a Canvas announcement about that. All right, and then a quick note, I know that some of you, if you have ARS accommodations, you've already reached out to me. Especially in the last day, if you reach out to me, I haven't had the chance to respond yet. However, if you haven't reached out, make sure to do so. Make sure to schedule the exam in the ARS Testing Center if needed, and they'll be able to work with you all for that. Are there any questions here? No questions. Good. Okay. So we're going to recall all the way back from lecture 1, this idea of our client and our server. We've been talking throughout the last few days about things like HTML, CSS, JavaScript, and we've really been diving into TypeScript and the features regarding higher order functions, functional programming, etc. Right? But ultimately, again, as we have been learning in this module, how does the internet work? Well, we have these two different kind of classifications of devices, right? We have our client, which is our laptops where we are actually loading our websites, and then we have some server. And the job for the server is simply to respond with the files necessary for that website to work on our computer: HTML, CSS, and JavaScript. Right? So whenever we load our websites, our browser is requesting these resources, these files from the server. Right? And in addition, if your website has things like images, which your personal portfolio probably did, then you will also be requesting images, perhaps, from the server and download it so they can appear on the website. So there's many different types of files that we can fetch. However, files are not the only thing that we can request from the server. What we're going to see today is that not just files, but we can also request raw data as well. The server might be responsible for holding some data or calculating something, and we might want to request that data directly from the server. So instead of a file like HTML or CSS or JavaScript, we get some raw data instead. Right? And so in order to load this data, like we do when we go to a URL and we get some HTML back for a website, there is a route that we some server will end up exposing that allows us to access this data, right? Some route or some URL. This URL, if its goal is to respond with some data, is typically known as an API endpoint. Okay? So API, if you have not heard of this term before in any of the other classes, stands for Application Program Interface. Right? So all an API is it is this idea that it is an entry point of communication for some system. Right? So for example, our server, if it has an API endpoint, it is an entry point where other computers on the network can communicate with the server to get some information out. All right, so APIs can be viewed generally. In this case, though, they're just a specific route that the server, whenever the server gets that, whenever a client tries to request a resource at that route, instead of getting a file back, we get some raw data. Yeah. So let's try this out. So I have an example URL here. You're welcome to copy this. If you have the slide open, I'm also going to do this, where I have some server that I have set up. And if you go to this URL, instead of getting a website, you're going to get raw data back. And there's two different ways to do this. We can either just like our browser, we can use our browser to make this request, or you can even use the command line. I'm going to show both examples here. So if I go into my slides and I copy this URL, I'm actually going to open this in Chrome because Chrome makes it kind of nice. So if I paste this in, right, you can see here that now what has appeared in our browser window is no longer a website, right? This is not anything that looks particularly great. It's not been styled. There's no elements here. It's just raw data. And if you're in Chrome, there's also a check mark at the top left, which makes it easy to make this a little bit more readable, called Pretty Print. So if I check mark this, you'll see that we end up with something that's a little bit more readable. You can kind of see that you might be able to now pick up a pattern as to what's going on here. If it wasn't clear from the URL, this is loading information of CS organizations as part of UNC Computer Science. You can see things like App Team is in there, CS Social Good is in there, CADS, Carolina Analytics and Data Science is in there, et cetera. Right? Now, we can also load this data directly from the command line using the curl system utility. I'm going to show this as an example here. So I'm going to open up my terminal. And I'm just going to, I have my URL that I've copied. I'll copy it again just to be sure. And you can try typing in curl and then paste in that URL, and you'll see that we can also download all of this data directly in our command line. Right? Now, curl is usable for other things as well. It is usable for websites. All curl does is it makes a request to some URL. So even though I've shown it here with data, you can do this with a traditional web page too. So like if I typed in curl, and then let's say that I try csxl.unc.edu. Actually, let me try a different one here, because I think there are some permission issues with that. Let's just try apple.com. So curl apple.com. There we go. So you can see here that it's telling me there's a bit of there's information that the particular URL, it actually wants me to use www.apple.com instead. So I'll do that here as an example. So www.apple.com. There we go. So you can see a lot of stuff is printed out here, but this is actually all of the HTML of apple.com. Right? So just like when you make a request to a server using your browser and it brings back a website, right? Just showing here, this is the same thing in the command line. It's giving us that HTML. Right? So that's a little bit of a digression, but it's sometimes if you're working with different programs or different scripts where you need to access website data, you might use this particular system utility. All right. So let's go back here. And this particular data, if you look at it, we have a very specific format that we're using here to represent our data. It kind of looks very similar to something like maybe a Python dictionary as a data structure, where we have these braces, and then we have kind of these objects. I can make this a little bit bigger because I realize that this is a little bit small. So let me zoom in on this. There we go. Right? We have data, which is a key, and then associated with it is a value, which in this case is a list of organizations. Inside of one of these organizations, between these curly braces, we have different properties, like the name of the organization. Right? We have name, and then the name of the organization is mapped to, in this case, App Team Carolina. We also have shorthand, which is just a shorter, abbreviated version of the name, and then we have a description as well. So you can see that we have this mapping of keys, which is some descriptor of our data, to a value, which is some record in our data. And this particular format that we are using here, let's go back to the slideshow. Right? This particular data format is called JSON, or JavaScript Object Notation, as it is kind of abbreviated. Right? So you can see in there JavaScript Object Notation, right? So this is kind of representing JavaScript objects, but just in a textual way. Right? Again, JSON specifies values and specifies data in this key value format. Very similar to, again, a dictionary or a map data structure that you may have seen before. We have a key, and then associated with that is some value. And the good thing with storing and representing our data and our servers sending back data in this format of JSON is that it makes it very easy for us to take data in this format and then represent them as objects in our code. It's kind of part of the name here in terms of JavaScript object notation, right? This idea that we have this textual representation and we want to convert it into objects in our language. But there's a standard format for how this works. And the good news here is that, of course, web apps are only one type of application. You could have different applications written in different languages. So for example, iOS apps might be written in Swift. Android apps may be written in Kotlin. You might be maybe working with some program or service written in Python. And the good news is that if our data is all represented in a very kind of standardized format, then we can load this type of data into other applications as well. And so if we have one standard that we follow, then all of our other applications can parse and work with that data that is given back. Any questions here so far? All right. So the question is then, is that if we have some data, let's say we have this CS organization's data, and we want to create a website that shows this data. Right? So this idea is that we want to go to the server, get that data, and then do something with it in our TypeScript code. So how do we go about loading data from one of these API endpoints in our TypeScript code? Right? So there is a very nice function built in to JavaScript TypeScript called fetch. And all fetch does is it's going to go to some URL, and it's going to grab the data that the server gives back, and then we can do something with it. Right? So making a request for us to an endpoint, and then return back some data. There's a problem, though, with this, which we're going to see. We cannot just run something like this, where I create a variable named data, and then I call my fetch function, pass in the endpoint, and then continue on with my program. Why is that? Well, if we think about even back to our memory diagrams and how we worked with JavaScript, TypeScript, one thing you've probably noticed, right, is that we're working with our memory diagrams. We have a stack and we have a heap. We have only one call stack. Right? JavaScript, therefore, is a single-threaded language. So what this means ultimately is if there is one call stack, we can only perform a single operation at a time in our program. Right? We run line by line, and we're going to essentially compute one line, move to the next, compute that, move to the next, and so on. And the problem that we end up with when we are fetching data is that fetching data is a very slow process. Right? We need to connect to the internet, we need to request the data, and then we need to retrieve the data. Right? So there's a lot of different steps that happen in this process, and this can take a while. Right? Connecting to the internet, as you all know and probably have experienced in Citizen before, is that internet speed can be really slow. You try to load something, it takes a long time to load. Or maybe you're trying to get a lot of data back from the server. Let's say you're trying to get a list of all of the computer science students, right? I think there are thousands of students in our department. That could be a lot of data at once, and therefore it would be very slow to fetch all of that. Right? So depending on things, again, like internet connection, size of the data, anything else, this process can take a very, very long time. What are the implications then of this? Well, imagine we have a script that looks something like this, where we have console.log start, we fetch our data, console log data, and then console log end. Right? We would start off, we would print out start, but then once we get to this line where we're fetching our data, things might pause because, again, this is a long process. We start fetching data, but it might take a long time for us to get any result back. And remember, TypeScript is a single-threaded language, which ultimately means then that our program is entirely blocked from doing anything else while this particular fetch call is running. All right? And the implication then is if execution is blocked, meaning that if we're stuck doing some process that takes a long time to run, well, then nothing else can happen on that page. Any other functionality that you might have, whether that be event handlers, whether it be animations or you're moving a mouse, everything is frozen. You cannot interact with the site at all, right? Because no JavaScript can run during the time that our data is being fetched. Right? And so even though fetching data might be maybe 100 milliseconds, 200 milliseconds. If you have a lot of that happening in your program, your user, if they're trying to interact with something, they will notice that nothing is happening while that's happening, right? Because our program is running every line really, really fast, right? Back to back, back to back. There's no real hiccups in that process. But if we introduce these operations that take a really long time to run, then the user will begin to notice the fact that the application is freezing, right? So this is obviously very bad, and we then would need a way to prevent these what we call expensive operations from blocking our thread. Right, so when we use this word expensive, usually expensive means, right, resource intensive in some way. Sometimes that's space intensive. In this case, it's expensive because we are expensive in terms of time usage. Right, so when I call an operation expensive, I'm saying that it takes up a lot of time in order to complete. And so the solution then ultimately for this problem is asynchronous programming. So in a course like 301, you may have, I'm honestly not fully up to date on what the 301 curriculum contains. They might talk about asynchronous programming. If not, though, today you're going to see how asynchronous programming works in the context of JavaScript and TypeScript. Right? So are there any questions here so far? All right. So what is asynchronous programming? Well, the entire idea with asynchronous programming is saying, OK, what if we start some expensive process, let's say fetching data, takes a long time to do. Let's say we start it, but we basically offload that process to the browser to complete. So the browser can worry about that and do it in the background. While that is going on in the background, we're going to continue executing code, right? Because again, the idea is that instead of waiting for our fetch call to finish running, let's instead continue on and do other things. And then once our data comes back, then we can do something with it. Right? So the idea is we start some expensive long process. It's moved to run in the background. And we are going to, and the browser is going to take care of that. We'll actually see this on Tuesday, how it works in the sense of, because we said JavaScript, right, is single threaded. So we're assuming that JavaScript is running one item at a time, but our browser also can do some other things, such as fetch data in the background and so on. So we're saying let the browser do that. We continue executing our scripts. And then whenever that process is done, the browser will notify us as it will notify the program saying it's done, and then run some code with the result. Yeah. So I have a script here to kind of showcase what this will look like. At the top, I have console log start, which is saying that we're just starting our program. And then I have a function here called perform expensive operation. And inside of this, I have my expensive operation. Let's just say that this is some arbitrary function. It takes a really long time to run. Right? So to use asynchronous programming, what we do is we mark that call to an expensive operation with our await keyword. Right? We're saying that this particular operation is going to take a long time to run. We'll add the await keyword to it. Okay? With that, any function then that contains an contains a await keyword, like so, we have await expensive operation. Any function that runs one then needs to be marked as an asynchronous function. So you can see here my expensive operation, we marked it with the await keyword. And then our overall function, we're going to mark with async. Okay? Any questions so far? All right. So then what actually happens then if we were to run a program like this? Right? So the way that TypeScript handles it is when we call an asynchronous function, instead of returning some data back, like in this case, we're loading CS organizations, instead of returning that back, it's going to instead return an object called promise. Okay? Now, promise is a generic object. So it wraps around whatever data that was initially supposed to be returned. So if I was returning a string, what we would instead return would be something like promise of type string, like this. Right? And the idea here is that our promise object, you can think of it almost like an empty shell or an empty placeholder. right? We're saying that we've kicked off some async operation. It's going to happen sometime in the future. We're going to promise that sometime in the future, this is going to be filled with some data, right? We're not guaranteeing that like immediately we have any data returned, right? So we're just saying this is an empty shell. We'll have data at some point in the future filled in here, but this will allow us to continue running our program if we don't have any data immediately filled in. All right. Are there any questions with this? All right, we'll see some examples with this. But again, you can just think of the fact that we are running an asynchronous function. The idea is instead of blocking our program and saying we cannot continue running other code until we get a result, we'll just continue running. And then at some point in the future, when our data is returned, then it'll be filled in. Yeah.
Still saying await operation. Would it not like pause until that operation is done, or is that still set as aside?
Good question. Yeah. So the await keyword is what essentially kicks off that operation to complete. And so when we mark our function with await, what we're saying is that ultimately the return might happen in the future. It's not going to happen immediately. Yeah. All right. So what I would like you to think about now, then, is consider the same script. Assume that the expensive operation, maybe it takes a few seconds to run, but it's ultimately going to spit back out the string I love conf426. Right, so I'd like you to think about what would we then expect this program to execute, or sorry, output, when we're done running it. So you can see in the bottom here, I added console log end and then console log result. So talk with the people around you for around 1 to 2 minutes. Think about what we might expect to happen here, and then we'll come back and talk about this together. All right, everyone. I hope this is on. But does anyone have any initial thoughts or any comments or concerns about this particular question here? Any idea on what the output might be, or does anything look a bit, or you're not sure? Yes. Yeah, so I guess I will say that is what you would expect to happen, right? Is that you would have end print out, and then our result here will end up printing out. I'm going to show you though, and this, if you're wondering that, because this is a little bit of a trick question, because I wanted you to think about this, right? What we would actually end up with would be something that looks vaguely like this. We would have start, we would have end, and then what we print out next is just going to be the promise object that we have. The reason for this is because if you think about it, our program runs these lines extremely quickly, like nearly instantaneously back to back, right? So we will print out at the top console log .log start, right? So we'll run this line, and then immediately we're going to run this line, and then immediately we'll run end, and immediately we'll run this console log result, right? So there is no guarantee that our expensive operation is going to finish by the time we get to this console log, right? Because these 3 lines are essentially happening back to back with very little time in between, right? Maybe 1 millisecond for all these 3 to run. However, that expensive operation might take a much longer time, like 100 milliseconds or 200 milliseconds to run, because it's an expensive operation. It takes a long time. And so we're not going to get our result. We can't guarantee that our result exists by the time we run that console log, right? To kind of illustrate this in a diagram here, I have 2 columns. I have my execution sequence, and then I have this async process column to kind of help us think about how this runs. Okay? The first thing that we run at the top, console start, right? So we're going to print out start. Then we call our perform expensive operation, which is down here on this line, result equals perform expensive operation. That's going to start some asynchronous process. And then immediately, we're going to print out console log end, and immediately print out console.log result. Right? It might be, though, sometime later, it might be some time before our operation ends up actually completing and giving some result back. Right? So you can see that our result's intended value, that coveted string, I love comp426, is not actually going to be returned until after we get maybe sometime later, however long, however slow our internet is, etc. Right? And so the entire idea here is that we can really only do something with this value after we find it. Right? So our current way of trying to get this result back is obviously not correct. It's not going to work because we have no guarantee in our current setup that our operation completes. All right? So instead, I'm going to show you now how promises are actually supposed to be dealt with, which is going to be with this syntax. So what we do is instead of saving a variable where we say const result equals and then perform expensive operation, we're going to call perform expensive operation, and there is a method on it called .then. What this particular method takes in as a parameter is another function, right? So this is why, again, this is another example where higher order functions are showing up in TypeScript because they show up very, very often. Right, so you can see right here, this is a function that is being passed in to my then block. And all this function specifies is what are we going to do with our result once we retrieve it. So we'll assume that the result is the input into this function. And then once we have it, we can then do anything we want with our result, including logging it out. All right, so again, here, I may have jumped slightly ahead of my little annotations. All right, so our promise objects have a then method that take in a function as a parameter. This function, again, is how we deal with our result once we have it. All right, so once this asynchronous operation completes, the promise object will call this function and pass in the result as the parameter right here. So this function will only run once our result once we get our result from this asynchronous process. This, again, allows us to do something with the result. Right? So how this looks in our execution sequence, to kind of illustrate this, we start off again with console log start. We then call our perform expensive operation function. That's going to kick off our asynchronous process. We will now console log end right here. And now that is the end of kind of our main synchronous sequence of operations. Sometime later, our asynchronous process is going to complete. And then the function that was passed into the then method is going to be called. So this function right in here, from here to here, is going to be called now that our operation has completed. And when I say this, what I'm saying is that that function is added to the call stack. Right? So we add that function in, we run it just like any other function call, and we will now console our result out. Right? So now our output here is correct. We have start, we have end, and then we have I love 426 because this console log did not print out until we had a guaranteed result from our operation. Yeah, question? Mm-hmm. It will likely print a, so in the other example, and I can go back to it just for, there we go. So in this example here, the result variable is actually going to be that promise object. So it's just going to print out like a promise. So it'll look something vaguely similar to, let's go back here, vaguely similar to this, where it's just a promise object and it says its current state is that it's pending because we don't have a result yet. Yeah, so it'd be something like that. Yeah. Good question. So the only problem with that then is if we have an await operation, the function that it's in also has to be marked async. And since we're at the global scope, there's no way to mark our global script as async. So that wouldn't work. However, if it was nested like inside of another function, then you could do that. The only thing is ultimately, every time you have some operation awaited, it's going to be in an async function. And calling an async function will always give back a promise. So you'll always have to work with the promise in some way. Yeah, yeah. Mhm.
And did the program keep that or enough for it to get back? So you have like a way to what time it is? So
That's a good question. So if you added some sort of halting process, then it would probably, you would, if you timed it right, you would get a promise with a result in it. So instead of promise pending, it might say like promise complete or success or something like that, and it would have some data in it. The only problem with that is, while it is possible, in a lot of cases, you know, the amount of time it takes is not really known. It could be very fast. It could be very slow. There's different variables that are associated with that. And also, again, if we have something like that, if we have a wait clause, again, our program, like our website, will be entirely frozen. Yeah. Good question. So yeah, how this works, and actually we're going to be showing this on Tuesday, and actually how the browser works, because this will help. What happens though is we're going to run our script, and that, if we think of our call stack in the heap, right? We have our operations, right? We run everything, we add onto the stack, and what'll happen is with these promises, once the promise is done, we will add another frame onto the stack. So you will, your program, even though your main script may finish executing, JavaScript is still waiting, like JavaScript as the runtime is still waiting for any other stack frames to be added after the fact, right? It's kind of the same way with event handlers. So let's say you have an event handler on clicking on a button, right? Our script finishes running before we press that button. But once we press that button, then we call that function. And so even though our script is done running, JavaScript as a whole is still running. So we can call extra functions as we need to. Any other questions? Good questions. All right. So another thing here I want to note is that we handled, wait, let me go back. Let me catch myself back up to where we were, which was here. There we go. So another thing is that there might be a situation where our expensive operation fails at running. And an example of this, maybe we fetch and our URL is invalid, or our internet shuts off randomly in the middle, or something, you know, some problem happens. We can also handle the error state using the catch method. So we have a then method on our promise where we can register some function to run on a success case where we do get some result. But if there is an error that happens when we're trying to do it, we also have a catch state. Okay, so this is just some extra information. If you need to handle an error, then you can. So for example, a good example here might be if you're on a website that shows all of the computer science organizations. If you successfully get those, sure, you can show them on the website. And if there's an error, maybe you want to display to the user, sorry, there was an error fetching, please try again, right? Something like that. So sometimes you'd want to handle that error case. All right, any questions here? All right, so now knowing this, we're going to, I want you to think about this example here and try and figure out what the order of our output is going to be. So I have two functions. I have cat, which has some operation in it that's going to take 500 milliseconds. I have dog, that's some operation is going to take 100 milliseconds. And then I have console, I call cat, two, I call dog, and then I have another console log. All right, so think about what would the order of these outputs be, right? So ultimately, when a program's done running, somewhere 1, 2, 3, cat and dog, right, should print out in some order. What is the order of that output? So spend around 3-ish minutes with the people around you to discuss this, and then we'll come back and talk about it. All right, everyone, I think we had a few minutes to discuss this. Does anyone have a hypothesis of what the answer might be here? Yeah. 1, 2, 3, dog, cat. Who is it? Whoever got that, raise. Good. Okay, so yeah, that is the correct answer, which seems a little bit strange here because again, we have the order of our code is 1 cat, 2 dog, 3, and even if you think about it and you move the async functions later, then it looks like 1, 2, 3 cat dog. But yes, the answer is 1, 2, 3 dog cat. So let's take a look as to why. So the way that I sometimes like to draw this out, there's various different ways that you can kind of work through these problems. One way that I typically like to do it, and you'll see, is for these operations that's going to take a certain amount of time, you can almost draw like an arrow off to the right to kind of indicate how long it will be. So the first thing we want to do is we want to run everything synchronously, right, top to bottom. So for example, we run console.log1 first. And so our output, 1, is first, right? Then the next thing we run here is this cat operation. And cat, well, we said here that cat's going to take about 500 milliseconds to complete. So I can kind of draw here like 1, 2, 3, 4, 5, right? This is like 500 milliseconds, roughly speaking, right? It's going to take 500 milliseconds to complete. And then 500 seconds later is when we'll get some result back. And so remember, because this is asynchronous, we're not going to just stop here and block our program. We're going to continue running the next steps. So what's next is going to be this console.log2. That is our next operation that we run immediately after. So our output of 2 shows up, right? Then what is next here? Well, we run dog. And this dog operation we said is going to take 100 milliseconds. So I can kind of draw a little shorter arrow here. That's like this is going to happen 100 milliseconds in the future, right? Again, we don't block here. We continue going. So I can say, all right, well, what's next that we can do synchronously? That's going to be this line, which is going to print out 3. So now we have output of 1, 2, and 3. And now we can say, now that we've finished everything sequentially, because again, we're assuming that sequentially is running extremely, extremely fast. So it's never going to, in any example that I give, I'm going to give very large delays so that you never have to worry about, will we have something run, right? We're just going to run the entire, what we can synchronously, top to bottom, then worry about our async cases. So then the first thing that's scheduled to happen is going to be our dog operation completing 100 milliseconds in the future. And so since that is now completed, we do have a result now that has been outputted. I just left, we don't really know what this result is, but some results outputted. And so therefore, we're then going to run the function that is inside of this then block, right? So we'll say here that, and I'll kind of match my colors, we run this. And so our output here is dog, right? Next, because that was the next thing that was scheduled to happen. And then 400 milliseconds later, our cat operation completes. And so now that the cat operation is completed, we are going to run this function, which has been registered to happen once cat completes. And our result here is going to be cat. All right, so our answer then would be 1, 2, 3 dog cat. Any questions here? All right, so one thing, again, like I said, these arrows are helpful. You can kind of draw them proportionally if it helps. Or you can just sort them based off of the time. In this case, I kind of draw sometimes lines as just 100 millisecond increments. Usually, if I give any question like this, or if I ever, any of these examples, will always be some large number, like 100 or greater, and usually increments of 100. It's like 100, 200, 300. That's just the way that it makes it easier then to solve as well. So now we have a more fun one. This is the attendance question for today. So what I'd like you to do is to think about the output here. This is a bit of a challenge, I will say, because we're combining now what we had from Tuesday with higher order functions with asynchrony, just to kind of make us think about what is actually happening, what is running in what order. So I think we have 2 functions. We have foo. Now notice that foo also returns an async function. That's where a higher order function comes in. It tells you how long these run. And so try to find the output, and then we'll come back together. You can also ignore the thing about the selfie in the paper. We don't have paper today. You could just type in what you think the answer is into the box, and that'll be fine. All right, everyone, quick note. If you already submitted your Gradescope submission early, because we forgot to add this into the attendance check, try to refresh. You can edit your submission. There'll be a second question for a mystery word, and that mystery word here is boo. So just type in boo. That'll be the kind of making sure that you're here today in person. All right, so make sure that if you didn't add that in, you edit that in, and then we'll spend around 30 seconds for that, and then we'll go ahead and work through this and see what you all thought. All right, everyone. Make sure again that if you were submitting for attendance check that you added in the mystery word boo as the second question. Now, does anyone have any thoughts or would like to share what they think the answer for this particular example is? What is the order of our output? Yeah. Yes. Okay. So say she said boo, return, bar, return, boo. Everyone, or what do you all think? Raise your hand if you got that as well. All right, pretty good. So that is correct. I'm going to again walk through it. So great work. If you had that, let's work on this together here. All right. All right. So what are well, our first two lines are just creating functions, right? So no operation is really, there's no print statement happening there. So the first thing that happens is bar, which is this particular function call. Bar is run, right? But bar is an asynchronous function. We say that it's going to give a result back after 200 milliseconds. So I kind of draw out here, right? 100, 200 milliseconds in the future is when we're going to get some result. Remember, we don't block our program. We run immediately the next line. So we're going to go to our next line, which is running this foo method right here. Right? Now, if we look, foo at the top is an asynchronous function. And we're saying that in this function, we have one operation before we return that's going to take 100 milliseconds. So we're saying here that after 100 milliseconds, foo is going to return. Now, what it returns is not some value, but it's actually another asynchronous function. Right? So the result of foo, instead of being some value, it itself is an async function. But this should only take 100 milliseconds to return. All right. Now, one thing also note, because I actually forgot to mention this, but somebody in the front mentioned it, which is great. So you may notice there's this syntax here where there's no parentheses around it. TypeScript has a lot of shorthand notation for some of these arrow functions. So if you thought that this was a syntax error, there is like you can have parentheses around here, and that's totally fine. Another thing that's very common, I don't know if 301 covers this, but a very common convention in a lot of languages, including Python and Java and Swift and TypeScript, whatever, is if you have some variable that is going to be passed in that you don't use, you can just leave it as an underscore. So instead of giving it a name, if it's just a throwaway, then you can leave it as an underscore. So see, in this case here, I guess our top one with bar is a good example. Since bar doesn't return, or just returns like nothing, we could just leave a blank underscore there, and that'll be fine. All right. So that's just some extra syntactic sugar there. Okay, so we're saying that foo is going to return 100 milliseconds in the future. And now if you notice, there is nothing else underneath this operation, right? Those two are the only two operations kind of in our global, our outermost indent that we're running first. So then we now look at what we are remaining, what's remaining. And so what's remaining is, well, 100 milliseconds from now, foo is going to return. So we can say now that, okay, it's been 100 milliseconds. So let's say that we're here now. And foo is going to return. Well, what is foo going to return? Foo is going to return this function right here. Right? This is the return statement for foo. So foo is going to return an asynchronous function. And the asynchronous function has an operation that takes 300 milliseconds in it. So this result here, this result is that asynchronous function that we've returned. Right? Because again, foo returns a function. And so what is the result of my foo call? It's going to be a function. Okay? Any questions about that? The room got very uncharacteristically quiet when I said that. That's why I want to make sure. Is there any questions here? Okay, so again, the only thing here, this any result in these then operation, right? Our parameters for these functions is the result of whatever our async operation is supposed to be. So foo, there was what it was supposed to return was another function. So therefore, result is that function. Yeah. Sure. Yes, like the top one or this right here. Sure. Yeah. No problem. So that's a good. Let me undo these. So what happens here? We have foo, and I think the unfortunate thing here is maybe because also these lines are not. There's no line break, which might be the problem. So if I highlight, so I'm going to highlight this entire function right here. So this function, this is the function that's supposed to run when foo is done running. Right, so we're saying that we're going to run foo. Then once we get a result, which is stored in our result variable, we're going to compute, we're going to run these 4 lines. Okay, does that, okay. Yes, no problem. And then what happens in here, which we're about to get to, is that we call, because result is a function, we call that function and we say when this is done, then we run that console log. Okay? So again, 100 milliseconds have finished, so we start running this internal blue block, right? The first thing we do in this blue block is we call, let me use a darker color, we call res. That's the first thing we do, right? Res is a function right here. And we said that res takes, right? Res is this function that we've highlighted. Let me make this a bit bigger. Res is this function. So this function that we're calling is going to take 300 milliseconds to give a result, right? This is an asynchronous function. So from this point on, because we're already 100 milliseconds in the future, 300 milliseconds from here, we expect for res to finish running. Okay? Now from here, remember that we are currently at this line where we call res, and we are then running, where we run that asynchronous function, except there's one more line that we can run immediately after, right? Because this line, this console.log, this is not part of our async function. Because remember, our program does not block. So even though we are calling res, which is an async function, we don't wait here for it to finish, because it's going to take 300 milliseconds. So then we immediately run this line first. All right, so this is probably where some of the confusion may have been. It would have maybe been easier to think about it if this console log was above this block, just because logically it seems that it's first. But because this is an async function, right, we are going to start the async process, and then we're going to immediately go to the next line, as we did at our global scope. So our output here, our first thing that we output is foo returned, which also might make some intuitive sense, because we said that foo was the first operation that was going to give back a result. So it makes sense that foo returned is the first thing that outputs. Any questions with that step? Okay. So foo returned, we were here at this point in time, right? So then 100 milliseconds after, what is the next operation that's going to finish and return? Well, it's going to be our bar operation. It was bar takes 200 milliseconds, so that's the next thing to happen, which means that now that 200 milliseconds has passed, we're going to run this function. Okay? And our output here is bar returned. Does that, any questions here? All right. So now that is done. And now the final one that we're waiting for is this result function to complete, which will be, let's say, 200 milliseconds after that, right? Because this started here, it's 300 milliseconds. So that's the last thing to finish. And so the last function then we run is going to be, right, again, once this res function finishes, we run this internal function here. We run this function. Because this is a function we said that we want this to run when we get a result from our res function. And so because that is 300 milliseconds in the future, it's the last thing to run, we will then console log boo as our last line. Okay. Are there any questions here? Yeah. Yes, so the res function here is, so we call res here is being passed in. So if you look up here with this foo function, right, this is a higher order function because we call foo, and then what we end up returning is another function. So we're returning that async function. This is what we call res, this function here. Yes, so res is, we give the name res, right? Let me highlight that in, yeah, I'll circle this in green. So if we go back to our other examples here, where I guess maybe I'll write this maybe out, like some function dot then, and then we usually have some parameter like this. And this is our standard then call. Exactly. Yeah. So what happens is once the function is done running, the result of that asynchronous function will be placed in to that parameter. Yeah. Yep. So this function here, if it returns something, the return is going to be placed in this parameter here. And we just give it the name res in this case. Good question. Any other questions about this example? Again, this is the most difficult probably example we've done in the class so far because it combines everything that we have done, right? So this is like our final, this is like the final boss of the examples, right, that we've done. It's incorporating everything together. It's incorporating syntax, it's incorporating asynchrony, and it's incorporating higher order functions, right? So I will also note that as part of the midterm review, there are, I think I already have 5. I'm going to make even more, so probably be 10 or so, 15 questions that are very similar in structure. It's going to be async questions going from easiest to hardest. There'll be example solutions as well. So you can work through those at your own pace throughout the week as more practice, because I know this is, again, one of the harder ones. So it's kind of at the higher end in terms of difficulty. So we'll have many examples that you can work through that will make this a little bit more familiar. Okay? Any other questions? All right. So we went on this digression of about talking about asynchronous functions because of our example of fetching some data, right? So we said we want to fetch some data from the server. That's going to take some time. And so the good news is that the way that the fetch function is implemented in TypeScript, fetch itself is an asynchronous function. Okay? What that means is that instead of returning some data directly, it's going to return a promise. Right? So we can say fetch, and then we can write dot then. So you can see fetch is an asynchronous function. Do I have a... I have it written out here where we say const result equals await fetch. So if this is an async function, you could do it that way. Or we can treat this as a promise. And I want to show this example now. So I gave this originally, but due to time, I'm going to actually just work through this with live. That way, I think it might make a little bit, it'll be nice to see this actually working right in our code. And so what I'd like to do here is I have this example website. And the entire point of this website is I want to press this fetch button, and then I want the CS organizations to appear on my screen, right? That's kind of what we started off with. I have my 2 things here defined. I have a button. This is a reference to my fetch button. And I have an event handler that says when I click this button, I want some operation to happen, right? So this is kind of now also bringing in our event handlers example. And then finally, what you don't see here is there's like an empty container where I can put my organizations into once I get them. All right. So what we want to do here is we want to, and I have some to-do items that I'm actually, you know what, I'll actually keep this, but I'm going to move it to the bottom. That way you can kind of see a little bit more on my screen here. And this example, I think as I finish it, I'll be able to post the solutions as well. So you have it. So the first thing we want to do is when we press this button, we want to fetch our data, right? So we said that our data for organizations is available all the way back, if I go up to my slide, at this URL, right? So if I go to this URL, I go to it, there's my data. So what I'll run is I will run my fetch function, which is an async function. And you can notice here that when I highlight over fetch, you can see that it returns a promise, right? So you can now see the connection returns a promise object. What I pass in here is my URL, like so. And so now I have my fetch call. What do I have to add? Remember, to a promise object in order to handle the result. What's the name of that method? Exactly, then. So I'm going to say that once this is done, then I want to perform some operation, or I want to perform some function. I can define that function here, like so. And my result will be passed in as some parameter. So I'll say result. All right, like so. And now what's going to happen is we need to do something with our result. So unfortunately, the way that for some reason this API is defined, if I were to write result.json, this should give me the objects of my data in JSON format. The only problem is this, for some reason, is also a promise. This is also an async function. I don't exactly remember the reason why, but because it's an async function, we need to do the same thing again, right? So we have to say, once we get the JSON of our result, JSON, we want to do something with it. Okay? What I'm going to do here, though, is I'm just going to print my result as a sanity check that this worked. So I can say in here, oops, console.log JSON. And if I open this in a new tab so that I actually have some output here, I go to my inspect tab, I go to console, I clear my console, and then I press fetch, right? You should see that I get now my data directly as an object in my code, right? I have object, it says data, there's all my information, app team, etc. And one thing we can do to make this a little bit easier, so if you highlight right now, you'll see that JSON is of type any, because our program doesn't necessarily know what is what is our data representing. It just knows it's JSON, but it doesn't really know. It could be any, right, JSON. So I've created an example type here, which is going to specify and say that our data is actually in that shape, where we have a name, we have a shorthand, and we have a description. Okay? So what I'll do here is I can instead just say const organizations equals JSON. And now remember, my object here, if I press this button, fetch, let me refresh here. Sorry, I removed my print statement, which is why it's gone now. Let's add that back just for our log JSON. There we go. Right. So our data here, the first field of our data is it just says data. Right. So we have one object that has an entry data, and then inside of data we have other things. So what we have to do is we have to select data. So if I show like a JSON.data and I console that out, you'll see that now I just get my list of organizations. Right, so I had to write JSON.data because that was a nested object. Okay. So from here, then I can just say, in order, because again, this is any, if I write JSON.data here, right, it doesn't know what shape it is. So now we can cast this to the type that we want, which is going to be a list of organizations. Right? So now if I highlight over organizations, you can see this is a list of organization data. And if I console log this, so if I move this down here, organizations fetch, you can see we still have our data, and this is now, we know it's typed as a list of organizations. And so finally, we're going to use what we talked about in our event handlers and, sorry, our DOM lecture, which is just saying, well, let's loop over our organizations. Right, so this is our for loop syntax for organization of organizations. And let's just create a paragraph that has the organization name in it. That's all we want to do. So we can write, and this is a little bit of review here. I'm going through this slightly faster because of our time limit. So we're just going to create a paragraph element. We're going to set what's in between our paragraph tag, our opening and closing tag, as our organization name. And now we're going to add this paragraph into our container, which we've defined up here. Like so. And now, if I go here, I refresh my page and I press fetch, you will now see, right, that on our screen we have a list of all of the organizations of the CSXL, or of the computer science community. Right? You can see just like that, we're now combining fetching, we're combining event handlers, we're combining the DOM, everything is coming together to add this functionality. Now, the last thing I want to showcase here is that our code this is completely functional. However, there is also a nice feature within promises where we can chain together then statements. So if like we have one asynchronous process that returns another asynchronous process, instead of having it nested like this, where we say fetch dot then, and then we say JSON result.json.then, we can actually do something very similar, but structured like this. So fetch our result. Then we are going to take our result, and we're just going to return here. Again, this is shorthand for result.json. So we're taking our result, and we're running the next asynchronous step. And then once we have that, we are going to do what we did before, which is iterate over our organizations. Right? So the only thing that's really changed here is the fact that I've chained together then statements, so that if we have multiple kind of asynchronous processes line by line, it will show up like so. And I'll prove that it works. Going back, press fetch, and everything shows up. All right. So that is all. There are like a few more slides here near the end. We're going to just pick that up on Tuesday. So we'll see you all. If you have any questions about any of this, please come to office hours. You can also check the email that will come out on Canvas for the review for the exam.